All right, so I posted this slide online. So if you have a computer in front of you, you can kind of follow along. So today I'm following pretty much same sequence of chapters as your textbook. How many of you didn't buy the textbook yet? Okay, all right. Everybody else has the textbook, right?
Except like it wasn't available on Amazon, so like it's like gonna get here like later for me, I think. I don't know.
You probably can buy it not just from Amazon, from other places as well. Yeah. Try it from who is the manufacturer? Wiley?
Barnes & Noble had it cheapest to rent.
There you go, Barnes & Noble. And check the Wiley, okay, the publisher. They may have the deal on the rent of the textbook, okay? So today we're going to kind of start actually getting more and more towards using the software. And my plan for this week is to show you how the software works, okay, at least the very basics of it. And also I'm going to start showing you how the graphs and visualizations are being created in JUMP. And next week we're probably going to discuss visualization using another tool which is called Tableau, okay? But first of all, I believe in the previous class we pretty much finished by discussing supervised versus unsupervised learning, right? This is important actually because for the rest of the semester we're going to study different methods that fall into one of these two broad categories. And the whole area of machine learning essentially is a lot of methods that are divided between supervised and unsupervised methods, okay? So we will revisit this thing over and over again. The new method that we're going to study every time, we will classify it. Is it a supervised machine learning technique or is it an unsupervised, okay? So let's kind of review it again. Unsupervised learning, what does that mean? That means that I don't have a specific target variable, right? So for example, it can be, one of the unsupervised methods is clustering. Clustering is grouping similar things together. That's simply speaking what clustering is, okay? So in marketing, for example, I can group together similar purchases made by customers, and by doing that, I can pretty much define what marketers call a profile or marketing persona, right? A typical buyer who, for example, buys lawnmowers, okay, or bunk beds, things like that. That, of course, will help me to advertise more effectively, right? So there is no specific column in my data set that I'm trying to predict. That's basically what unsupervised learning means, okay? There is no target variable or outcome variable or dependent variable. I'm not trying to predict certain things like sales, for example, okay? Another unsupervised learning method is called association rules. Sometimes it's also referred to as affinity analysis. And the bottom line of association rules is what goes well with what else. And we discussed the example with Walmart, right? Walmart tries to see cross correlations, if any cross correlations exist between the product sales in their database, and if they see that two items have a positive or negative, for that matter, right? Correlation, that means that they either sold together nicely, or if one goes up, other goes down, right? And that helps them also to drive marketing, right? If some items are well correlated with each other, that means they have to be positioned close physically in the store, right? Another couple of techniques is data reduction and dimension reduction. What's data reduction? Well, let's say, for example, I'm digging through my data and trying to cluster the data, okay? So that means that I found a group of records that look similar to me, right? So similar purchases, for example. Then I can separate these groups of records into a separate data file and try to work on just this subset of my records, subset of my data set, okay? For example, if I found that there is a certain group of customers that look alike, I may try to go ahead and see if, for example, I can run a regression analysis on them, okay? And see if I can predict sales if I advertise for these customers, or if I give them a discount on a certain item, okay? So essentially, after clustering, I'm going to kind of split my data set into the subsets, and each subset I'm going to treat differently, do the separate analysis on that. So that's called data reduction. So instead of dealing with, let's say, 1 billion records, if I split them into 1,000 of subsets, now each subset is smaller, right? And I can consider each subset separately. That's what data reduction is. Dimension reduction is a similar concept, but instead of splitting records, I'm splitting columns, essentially. So in other words, my data set can contain a lot of columns that may or may not be relevant, right? So for example, let's say I'm trying to predict which students will stay in the university after first year and which students will leave. Well, database contains all kinds of things, right? It contains name, first name, last name. It contains gender. It contains whether or not you're Greek affiliated with any of the Greek, societies, right? If you're on the financial aid, what's your zip code from, home zip code, etc. So if I look at all of my columns, I can say, well, you know what? First name and last name don't really matter. I mean, how can I predict if person will leave or stay based on their name? I can't do that, right? So I'm going to get rid of these things, right? So that's essentially the idea behind the dimension reduction. Instead of having 150 columns of data, variables essentially, right? I'm going to say, well, some of them aren't really important and I'm going to just get rid of them. They will not contribute to my model at all, right? And that will, of course, simplify the analysis, okay? Then exploration and visualization, also kind of unsupervised learning, because when I'm plotting the data, what exactly am I looking for? Do I have certain idea in mind when I start visualizing? Probably not, right? I'm just curious, kind of digging around, right? What if I plot the data distribution? What insights can I gain from that? Well, maybe distribution looks weird. Maybe it's like weirdly shaped or it has obvious outliers. That'll tell me how to deal with data later, right? But before I see the picture, I can't make any connections or conclusions or preconceived notions, right? You see the data and then you decide what you're going to do with it, okay? So that's unsupervised learning. Okay, as opposed to that supervised learning, it has a target variable. In other words, one column of my data set is something that I'm trying to predict, okay? And that variable is called target oftentimes. Sometimes it's called outcome, sometimes it's called dependent variable. So there are different multiple names, which mean essentially all the same, right? Now, supervised learning requires data to train the model. Train the model, essentially, it means develop a model that you can use later to classify or predict new observations, okay? So, in other words, let's come back to the same example, right? Students at CNU, some will leave, most will stay, right? I'm trying to predict who will leave. How can I do that? Well, one idea, and probably the only idea, is every year CNU admits how many students? About 1,200 to 1,300 students, right? And it would be nice if I could get the data on all people admitted last year, 2 years ago, 3 years ago, 5, 10 years ago. The more, the better, right? This data that was collected 2, 3, 4, 5 years ago already has all my necessary information inside, right? Every student either came back from the freshman year or did not come back from the freshman year, right? So I know already what happened in the past. I'm using that data to build my model. And the model will tell me how I should predict the probability, for example, of a student leaving, right? So this is a training set or training data. That's how I built my model. After the model is finished, I can apply it to the observations that I don't know yet. Therefore, I'm forming a prediction. Like, for example, this semester just started. This is the beginning of academic year, right? We have 1,300 new students, right, taking classes right now as we speak. Some of them will not come back a year from now, okay? Which ones? It would be nice to know from the university standpoint, right? So what I can do is I can take the model which I developed on my training data and apply to my newly admitted students. And the model will tell me for each student, that one is likely to stay, that one is likely to stay, but that one is likely to leave for one reason or another, right? So therefore, what I'm going to use and this is predictive models, essentially. They predict the future for me, for things that I don't know yet, okay? So I apply the data, the model to score the data that I don't know the outcome yet. I'm trying to predict the target variable, and the target would be student will leave in the university or student will stay in the university, okay? So two broad methods in this area are classification or prediction, okay? So what's classification? Leave or stay, okay? What's a prediction? Prediction is something that's numerical. So if a student will leave or if the student will stay, that's kind of one or another, right? It cannot be in the middle. So it's thing one or thing two. A prediction is something that I predict numerically. For example, if I raise the price by $1 on the product, how much the sales are going to be impacted. If I spend additionally $1,000 on advertising, how many more units can I sell? Okay, so predicting something numerical. Okay, all right. Okay, ladies and gentlemen, this is important. I know that all of you took BUSN 231 some time ago, right? How many of you took it last year? Just 2 people. How many of you took it 2 years ago? A few more. How many of you people took it 3 years ago? Oh God. How many of you never took it? Everybody took 231. Okay. So in 231 you learned data types, right? And we're going to review that because I'm not betting on you remembering it. Okay? I would rather go over them again. All right, data types are important because depending on the data type of your target variable that you're trying to predict, you will pick one method or another method. Okay? So it's important to know data types. Data types, the statistics deals with, fall into 2 broad categories. One of them is called numerical. What do you think is numerical? Give me some examples of numerical data.
Age.
Age, right?
Gender.
Gender, is it numerical?
No.
Male, female. There is nothing numerical about that, right? Okay, so age, income, right? Temperature outside. These are examples of numbers, something that we can measure with a number. Categorical, such as gender, are not numbers. Okay, they're categories. We can put a label on them, but it doesn't mean that they become numerical. Okay? All right, so these categoricals further are subdivided into the two more subtypes. Okay? So here is the data. All data that we can deal with has 2 different types. Okay? Numerical data. Sometimes numerical data also called interval. Sometimes it's called quantitative. The program that we're going to use in this class called JUMP calls the numerical data type continuous. Okay, it's a real number between minus infinity to plus infinity. And the other data type is categorical. So not numbers, but a bunch of classes or categories, right? Well, categorical is further subdivided into 2 subtypes. Okay, so categorical data can have a nominal data type or ordinal. And let's kind of discuss them. So let's start with numerical. Numerical, like I said, real numbers, right? Can be weight, temperature outside, can be prices of items, can be height of human beings, okay, salary, how much money people are making, anything. So in other words, I'm measuring things that are interval or numerical with numbers or quantities. I assign quantities for each observation. So therefore, this data type is also called oftentimes quantitative, as opposed to what? Qualitative, right. So therefore, categorical are oftentimes also called qualitative data. Okay, but let's go back to this one. Arithmetic operations that are allowed on numerical or continuous or quantitative data, however you want to call it, are very, very vast, okay, and different. I can do pretty much whatever the heck I want with numerical data, whatever makes sense. Okay, let's say, for example, I collect the height distribution in this class. So everybody has a certain height. I'm 5'7", for example. I'm sure there are tall people, right? There are not so tall people. There are people shorter than me, probably, right? So we can collect numbers about each person, right? In inches, for example. How many inches tall are you? And after that, what can I do with this? Well, I can calculate average height. I can see the maximum and the minimum, so I can compute the range, right? I can compute standard deviation. What does standard deviation measure, by the way?
Isn't it from how far your data is spread from the mean?
That's exactly right. Standard deviation tells you how far your data is spread to the right or to the left. If standard deviation is high, that means that you have a wide difference between different observations, right? Your data is very widely spread, okay? If your standard deviation sigma is low, that means that you're pretty compact around the mean. You don't go too far away from the mean. That's exactly right, okay? Then I can compute something that's called percentiles, right? Percentiles refer to individual observation. We can take any person and ask how does that person's height compare to the rest of the group, okay? Same applies to actually scores. That's a lot of universities. That's something that a lot of universities are using, right? When people apply to the institutions, every institution, including CNU, by the way, publishes 25th and 75th percentiles of the score. How many of you looked at these numbers when you applied to universities? Nobody? You looked at them? Yeah. Typically, well, my daughter just recently applied, right? Last year it was like application time. So every time when you apply, you want to know, are you in or are you out, right? So, and obviously you want to go to CNU or any other university website and find the answer, right? How much should I score in order to get accepted? What's the number? What's the magical number? Universities don't really tell you that, right? You know why? Because they don't know yet. Because who will get in and who will not get in depends on how strong the pool of applicants is going to be, right? Typically what happens is they accept students for the upcoming year, then they analyze what was the pool like, and then they publish the statistics about that pool. They say 25th percentile was this number and 75th percentile was that number. That means that middle 50% of people who were accepted scored in this range, right, between A and B, basically. So percentile calculation also makes sense for numerical data, okay? Outliers. What's an outlier? Just give me a brief explanation that makes sense. Like one sentence. Outlier is
a data point drastically outside the set of data.
That's exactly right. A data point which is drastically unlike the rest of the points, right? Like a person who is freakishly high or a person who is freakishly short, right? So something that doesn't look like the rest, the typical representative of a human community, right? Or a person who makes enormous amounts of money, or a person who makes suspiciously, low salary, right? So some observations that are not very far away from a typical or average or median, right? Okay, so that's numerical data. Highly privileged, as you can see, right? I can do a lot of computations on the numerical data. Well, on the other end of the spectrum, I have nominal data. Nominal data is one of the categorical data types, right? Remember, categorical has two subtypes. What are they? One of them is nominal and another is ordinal. There you go. Nominal. Nominal, as opposed to interval, is very underprivileged, okay? Here's some examples. If I go outside on the street and I start asking people, what's your marital status? I'll probably hear one of these four responses, right? Single, married, divorced, or widowed. That's it. Is there a specific order in these categories? No. It's not like it's better to be single or married, right? It depends on who you're asking, right? Some people prefer one way or another, right? It's just categories. But probably that covers 100% of the cases, right? Every person on the street that I will ask will tell me if they're single, married, divorced, or widowed, okay? So I can go ahead and formally assign labels, numerical labels to these groups, right? So instead of writing down single, married, single, divorced, etc., I can say every time when I hear the response single, I'm going to write 1. Every time when I hear the response married, I'm going to write 2. So when I go out and collect the data, all I'm going to get is a bunch of numbers. 1, 2, 3, 4, right? Bunch of these numbers. But really, they will stand for categories, okay, for these categories. So categories are not ordered. It's not like being single is better than being married or other way around, right? So there is no natural ordering between them. That's nominal data, okay? And because the numbers that I assign are random, right? I mean, I assign single number 1, married number 2. Could it be other way around? Yes, it could. Could I assign single 10, married 20, divorced 30, and widowed 40? I could, right? It's just a matter of what number, random number to assign to any group. That means that any computations that made sense for interval or continuous data, they don't make sense anymore because the numbers that I assign are random. They're my random choice. Okay. Say, for example, I meet two people. One of them is single, another is divorced. Right? If I can compute the average, 1 plus 3 divided by 2 is 2. On average, every one of them is married. Right? Is that the right interpretation, or is it a little bit out there, kind of wacky? That doesn't make sense, right? So therefore, I can compute means, I can compute standard deviations, I can compute percentiles, there are no outliers. None of the concepts that apply to continuous data, they apply to nominal data. For nominal data, the only thing that we can calculate is how many responses did I get in category 1, how many responses did I get in category 2, 3, and 4, and what are the percentages. Okay? That's it. That's the only thing. So, for example, I collect the data, and then I compute percentages. Turns out that in the society there are 33% single people, 45% married people, 19 divorced, and whatever is the rest is widowed. Okay, so I can compute just counts in each category, and what percentages do they represent. That's the only thing. Okay. Then I have another one, ordinal. Ordinal is still categorical, so it's very similar to nominal, but there is only one thing that ordinal data, there is one extra thing that I can do with ordinal data. Okay, I can compute the median, but everything else, it's very similar to the nominal. So ordinal data is categorical or qualitative, right? We discussed that categorical data. Another word for that is qualitative, right? They're not numbers, they're not quantities, but they're other qualities. Okay, so categories, unlike nominal data, now are ordered. There is a natural order. Okay, so for example, in marketing you see that a lot, right? When you check out of the hotel, they ask you, what do you think about services that you have received? Right? On a scale from 1 to 5, 1 being poor, 2 fair, 3 good, 4 very good, and 5 excellent, please give us your mark, right? Your rating, and you do that. It's not just exclusive for marketing. Pharmaceuticals sometimes use that, okay? So let's say I came up with a new painkiller. Painkillers are supposed to do what? Make people feel better, right? Is there a painmometer that I can hook up people and measure the level of pain? No, right? What I can do is I can find a group of people severely in pain, and I can give each one of them a pill, right? And say, hey, this is my new painkiller. Let's see what happens. And then an hour later, I'm going to ask them, so on a scale from 1 to 5, tell me what you feel. 1 means I still feel severe pain, 2 slightly better, 3 substantially better, 4 almost there, and 5 excellent. Pain is gone, right? So that's basically the only thing that I can do, right? Kind of gauge how much pain they are experiencing, but it's going to be subjective measurement, right? Not objective. I can't, like temperature, I can measure with thermometer, right? Thermometer is an objective thing. I can use different thermometer, will show me same temperature, right? This time around, when I'm collecting ordinal data, it's all subjective, right? What people perceive, right? Their personal perception, just like service, right? Some people will say, yeah, great service, I had a great night's sleep. Another one says, well, no, internet didn't connect. They have different set of qualities, right? They're looking at different things. Okay, so the important distinction, again, about ordinal data is that categories are ordered. So we can say that excellent is always greater than poor, right? And very good is always greater than fair, okay? Now, I can again assign, just like I did for nominal. Remember, married 1, divorced 2, single 3, so just my random choices, right? Same thing here. I can assign numbers, labels to different categories, okay? Now, this time around, they're also random, but I have to preserve the ordering. So, for example, I can assign 1, 2, 3, 4, 5, or I can assign 6, 18, 23, 45, 88. Different set of numbers, but what's important is they keep the same order as my original groups. Make sense? Any questions so far? How are we doing? Are we live? Say meow. Say meow. Meow. Wow. Are you hungry? I'm getting hungry. All right, anyhow. Okay, calculations. So, numerical data type, we discussed, all calculations are permitted as long as they make sense, right? So therefore, it's highly privileged from that standpoint, right? Nominal, nothing is allowed. None of the stuff that we discussed for interval data is allowed, except you can compute how many observations in each category and what percentages do they represent out of total responses, right? And ordinal data, the only thing that we can compute for ordinal data is the median. Well, let me illustrate the median, okay? Not that it's relevant for what we're trying to get here, but let's say, for example, I am asking the question, okay, to the students on the street. What do you think about the parking at CNU? Well, here, right, we have 10 people in the first row. All right, Zach. Oh, Zach is in the back. On the scale from 1 to 5, 1 being sucks, 5 being, oh, great, CNU has great parking conditions. What do you think? 2. Okay, so that's a 2.
Also 2.
2, okay. 2? Ryan? Oh, God. Is that like previous answer bias kind of thing? They said 2, I'm going to say 2 also. 3, huh? There you go. 4? 2? Okay. 5. Cool. 4. Amanda, 2. Okay. Well, let's get one more. Okay. 2. Okay, 2. So I have how many responses? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 responses. And I'm going to order them now, okay? Because I can. These are ordinal data, agree? So I have 1, 2, 3, 4, 5, 6, 7 twos. 2, 3, 4, 5, 6, 7 twos. Then I have a 3. And I have 2 4s. And then I have a 5, right? So 11 responses. What's the position in the middle? Medium, right? And it's position number 6 in this case, right? Why? Because here is my 6. Because I have 5 responses below that. And I have 5 responses above that, okay? So that's my median right there. Median is 2. Okay? That's the only extra thing that I can do with ordinal data that I could not do with nominal data. Because nominal has no natural ordering, right? This one does. So the only extra thing that I could do with ordinal data is to compute the position of the median response. But that's about it. Everything else, ordinal data is not much different from the nominal data. It's basically the same thing, okay? So here is the hierarchy of the data. Kind of a summary, right? Interval, most privileged. Very privileged data. Values are real numbers. All calculations are valid. Whatever makes sense for you, okay? Data can be treated as ordinal or nominal. In other words, I can dumb it down, okay? In fact, that's exactly what happens when we construct a histogram. We're going to get that probably next class. How do you represent the data with the picture, okay? When it comes to the interval data, or continuous, that's how JUMP calls it, how we represent the continuous variable with the picture is we plot the histogram. When you do the histogram, you're kind of grouping together all numbers which are in a certain range, and then range after that, range after that. So essentially we're saying every observation falls into one of these ranges. So I'm treating that as an ordinal data, essentially, okay? Ordinal data. Values are categories, but they are ordered, okay? No calculations are allowed except what? The only thing that I can compute about the median data is starts with M, ends with edian. Median, right? I can compute median. We just did that, right? About the ordinal data, okay? Ordinal data can be treated as nominal, but cannot be treated as interval. I cannot treat them as numbers. Although, I got to tell you, that's not necessarily true in all cases. Let me give you an obvious example. Do you realize that the grade that you're getting in any class is actually an ordinal data? What grades can you get in any class at CNU? Can be A or A minus, or B plus, B, B minus, C plus, C minus, etc., right? These are not numbers. These are categories, right? So your grade is an ordinal data. CNU then says, okay, actually, we're going to assign A the value of what? 4. We're going to assign A minus the value of 3.7, then 3.3, then 3 is a B, right, etc. And then the CNU computes the GPA, right, out of that. So CNU actually, and any university for that matter in the United States, It does basically something that's taboo, strictly speaking, right? You're taking ordinal data and you're computing the average, which you shouldn't be doing, right, strictly speaking, but that's what happens. We compute the mean with ordinal data, right? While the only thing that you can do is median, actually. Well, but anyhow. So, in other words, we treat the ordinal data as if it's actually interval in this case, right? And nominal data least privileged. There is no ordering between the categories. And I can do any computations except count how many observations in each group and what percentage of cases that count represents. Okay? All right, ladies and gentlemen. Let's do the InClass exercise now, okay? And let's pray to God that this thing works. I mean, software, okay? Well, first of all, let me give you kind of a brief overview, okay? Data analytics. Remember our very first or second lecture, I told you that the reason why data analytics is so popular is because computers are very powerful these days, right? We can't really do data analytics without computers. Because how can you take, for example, 5,000 students that are at CNU at any point in time and quickly compute things about them without computer program? You can't do it, right? You have to have at least some firepower at your disposal, so to speak, right? So there are a lot of programs out there, believe you me, okay? We're going to use a program which is not very popular, quite honestly, between us chickens, okay? So the program, but it's actually a cool program. The reason is, first of all, it's very simple, very easy to use, okay? That's number one. Number two, we're using the same program in our statistics class right now. Probably all of you took the statistics with Visa, right? You did Visa. Yeah. Not anymore. So new generations of students that will take statistics class will use JUMP. Same program as we're going to use in this class, this semester, okay? Number three, JUMP is very powerful in terms of it can do traditional statistics, as in BUSN 31. It can do data analytics models, and it can also do fairly powerful visualization, something that we'll start doing next class, okay? And probably for the rest of this week. So therefore, it's kind of a package deal. It's 3 in 1, right? So we're going to use JUMP, but there are other programs, okay? So JUMP is what is being used in this class. By the way, JUMP actually it stands for John's Macintosh Project, okay? This program was started in 1980s, but by one guy who was essentially, his idea was to create a statistical package, okay? And then the program became bigger and bigger and bigger, and at some point in time, a big company called SAS bought it. Okay, so SAS is actually one of the most popular tools these days in the industry. So a lot of companies are using SAS for their data analytics. Very popular package, okay? But JUMP is kind of a subdivision of SAS. So myself, I personally view them as a little bit competing products, okay? The difference probably is SAS is a heavy artillery. It can work with large data sets, distributed data sets. Database can be split among many computers, many hard drives, and it can still do the calculations. JUMP, you see it in front of you. So it's a one-user program, okay, installed locally, working with a data set that resides on your machine, physically in front of you, okay? SAS is more powerful, so it's more like heavy artillery. Then there are a lot of companies these days that also use a product called R, one single letter, R. What's cool about R, how many of you heard about R? Probably a lot. Right? What's cool about R? R is free, and it's open source. These things are not free, and these things, SAS is, oh my God, how not free it is, okay? Yeah, it costs a lot of money. R is open source and free. You can download and install it on any computer, on your own computer, okay? Then another program, it's not a program really, it's a programming language, Python. Python is actually getting more and more popular, and especially the combination of R and Python is being used in a lot of companies. They write programs in the programming language Python that call the R to do the statistical computations from inside this Python program, okay? So we're going to use JUMP in this class, and let's go ahead and see if we can launch JUMP. So go to Start menu. Okay, unfortunately here I don't have a start menu. That's a different Windows system. So click on the start, and there are all programs, okay? And there you should see JUMP Pro 13. Do you see it? jump row 13. And probably you click on this icon, it expands, then go ahead and click jump row 13 so that you run the program, okay? And I'm going to do the same thing over here. So let me close that. So this is what happens when you run it. Do you see this window that says tip of the day? What do you see?
It's asking us to meet a register.
Oh, register. There is an option register later, right?
Wait to register.
Yeah, wait to register. So don't register it. Just say wait, okay? Do you see tip of the day? Window, just close it. Say close. And you should see window like that. I have a bunch of files because I used files lately. Do you see a bunch of files in front of you? It should be pretty much empty screen, right? Okay, good. So let's do an exercise. Hopefully it's going to be a quick exercise. Well, here, right? Suppose I'm a meteorologist guy who wants to track weather conditions in the city of New York now during 7 days, right? Sunday, Monday, Tuesday through Saturday. Okay, cool. So I'm going to record this data. Day of the week, 0 will stand for Sunday, 1 stands for Monday. In the United States, you start with Sunday, right? Week starts on Sunday, right? Kind of, sort of.
Yeah.
Sunday, Monday, yeah. Because I'm Russian, right? So Russians start week on Monday. So it required me some cultural adjustment. Like first, Monday actually is not the first week. Okay, so my first column is going to be day of the week, and then temperature, highest temperature of the day, lowest temperature of the day. Then it's going to be a column that says how sunny was the weather. Two things, 0, mostly not sunny, so it was an overcast, right, or something like that, and 1, mostly sunny. Sometimes maybe clouds, maybe not, but mostly sunny. Another column will contain how rainy was the weather. 0 again, mostly not rainy, and 1 mostly rainy. So let's go ahead and create this file. Okay, so say for example, this is the data that I collected. Okay, I recorded that on a piece of paper. Now I want to put that in the electronic form. So everybody has the jump open, correct? Cool. All right. So I'm going to go to the file and say new data table. Click, and there it is. Here is my new data table. What does that part look like to you? Looks like Excel, right? So my data will look like a lot like data table Excel. Data, individual observations are rows, horizontal lines. Columns that contain similar data are variables, right? Okay. So column 1, you should have column 1, right? So go ahead and double click on the title that says column 1, and you will see the window like that. It says column 1 jump row, right? So column name. Well, let me go back to my slides. First one is going to be the column that contains the day, right? And I'm going to have Sunday, Monday, Saturday. By the way, Sunday, Monday, Saturday, what type of data am I dealing with? And I have 3, right? Continuous, nominal, or ordinal. What do you think that is? Continuous? Ordinal or nominal? Ordinal. Why ordinal? Because Monday comes after Sunday, right? And Tuesday comes after Monday. So they're ordered, right? So it's an ordinal data. That's true. Okay, so let's go back. So I'm going to rename, column name is day, right? Data type is, well, let's keep it as numeric, because I'm going to give it labels, right? 0 through 6, right? But modeling type, I have continuous, ordinal, or nominal, just like what we discussed. So I'm going to pick ordinal, right? Okay. So I'm going to click OK. And therefore, over here, I'm going to, well, let me go back to my slides. What do I have? Sunday, which is 0, then next Monday, etc., right? So let's go ahead and do that. So my first day is going to be 0, and then 1, 2, 3. So I'm just going to type and hit enter, okay? 4, 5, and 6, right? So that's my week. Starting from Monday, going all the way up to Saturday, right? No, starting from Sunday, right? What if I want to display them as Sunday, Monday, etc., etc.? I can do that. Well, how are we doing so far? Any questions, problems, concerns, complaints, sarcastic comments? Anything? Say meow. Yeah. Okay, so now let me go ahead and change the view a little bit, okay? If I go ahead and double click on the title one more time, so that it shows up the same window for me again, okay? Do you see at the bottom of this window there is something that's called column properties. So go ahead and click on the column properties, okay? And it has option that says value labels, right? Okay, so go ahead and click on the value labels. Value of 0 corresponds to what label? Sunday. Sunday. And go ahead and click add button.
Do you have a dash after the
Oh yeah, 0 dash, yeah, sorry. 0 corresponds to Sunday, okay? And then you say add. Then after that 1 corresponds to the label Monday. Click add. 2 is Tuesday. Add. 3 is Wednesday. 3 is Wednesday. Okay. 4 is Friday, right? No, Thursday. 4 is Thursday. 5 is Friday. Add. And 6 is Saturday. Okay. And I click add. So here's my list, right? I have values 0 through 6, and they correspond to the labels Sunday through Saturday, okay? And right there is a checkbox that says use value labels, right? You see that at the bottom, checkbox? Yeah. So now if I click OK, it doesn't show 0 through 6 anymore. It shows the labels, right? Because of this checkbox, essential, okay? I'm telling the jump that, hey, you need to use the labels that I assigned to my numbers, 0 through 6, okay? I can go back, obviously, right? So if you double click and you uncheck this checkbox and you say, okay, go back to 1, 2, 3, 4, 5, 6, okay? Make sense? How are we doing so far? Oh, one thing to notice, by the way, ladies and gentlemen, is this thing right there. You see what happened? We just created one column, which essentially is a variable, right? All my variables are columns. All my records are observations, data instances, data points, okay? So I have only one column, one variable, day, okay? And what's important also is that the icon next to the name of your column will tell you what data type is that. So let's kind of mess around a little bit, right? If I click on the word day, turns out if I, no, hold on. Yeah, if I click on the icon next to the word day, it shows up choices for me, right? Right now it says it's ordinal data that you're dealing with. And that's true, right? We set it up as ordinal data, okay? Can I make it into nominal data? Well, let's try. I can, turns out, and look at that. What happens is the icon changes from red, kind of increasing bars to high-low bars, from green to red, right? So green is ordinal data, red is nominal data. Can I treat that as continuous? Oh, I can, because originally it was 0 through 6, right? Numbers, technically. I can treat them as numbers if I choose so. Continuous gives you a different icon, right? It's a blue histogram kind of thing. So by looking at the icon, you can tell which data type is that. But let's go back, right? So let's not do that thing. Let's go back to the ordinal data, okay? And because we're out of time, let's save it. You know how to save it? We have to click on the icon that has this disk image. And I'm going to save it on my desktop. Where's my desktop? Now, you can see that all the files generated by JUMP have the extension .jmp. Not a big surprise, right? So let's call it weather, okay? Weather.jump. Let's click Save button. Tell you what, we're out of time, but I will upload that file on the Scholar. And next time when we meet, on Wednesday, we're going to finish entering the data into JUMP. So this way you will kind of learn at least how the JUMP looks and how to distinguish data types, okay, etc. All right, so that's it for today.